Hi, everyone, and welcome to the HYPACK 3D Hardware and Sidescan webinar. My name is Brittany Hines, Marketing Specialist here at HYPACK, and I will be your host for today's presentation. Before we begin, I just want to remind you about the question box on the side of your screen. We will be taking questions at the end of our webinar, so please submit them using the question drop-down box. Also, if you are unable to hear us or the screen goes blanks, please comment in the chat box so we can fix the issue. So for today's webinar, we're going to show you HYPACK's improved 3D hardware setup and all of its new features. You will also see an operational tutorial with some handy tips and tricks to maximize the potential of your Sidescan survey. I would now like to introduce our presenter for today, Daniel Tobin, who is now in his 6th year of programming at HYPACK. We are excited to have him here with us today. And with that, I'm going to turn over the presentation to Daniel.
All right, hi everyone. Thank you, Brittany, for the introduction. Like Brittany said, my name is Daniel Tobin. I've been programming with HYPACK here in Middletown for about 6 years now, over 6 years, geez. So today we're going to be going over some of the new changes that have been made in the hardware setup program, and then that'll be sort of our halfway point, and then we'll switch over to doing some Sidescan survey a focus on how signal is processed in Sidescan survey, just to help you get a better image out of your survey. So the changes we made in hardware were sort of focused on adding features and improving the program. So you're getting, a better program for you're improving the tools that you already use. And with the Sidescan tips, I hope that we can also improve your knowledge and use of the Sidescan survey program to get the most out of it that you can. So some of the new hardware features include the sort of flagship for the hardware update this year, which is the 3D hardware visualization. So you'll be able to see your vessel and the attached devices in 3D. We also have another big feature is the all offsets table. So you'll see the offsets for all of your devices and all of their offset types in one place, and you can edit the values in that table. And we've also had a number of small quality of life improvements just to sort of improve the experience of using the hardware program. So I'll go over the little things that we've added. They might not seem like much, but the changes like these keep HYPACK great and keep things very usable and very very modern. So the first thing we did was just basically made the there's been a lot of small UI tweaks to this new version of hardware, but the most obvious is probably the extended device list. So scrolling through this list will be a little easier. We also have added back the feature to right-click on a device in the device list on the left and move it to your mobile or any other vessels in your survey. I know that feature had been in hardware a number of years back, and it went missing for a while, and it's been reintroduced. So those were a couple of the small quality of life features we've added. The one of the big features is this offsets table view. So there's a new tab in hardware that will show all of your offsets in one place. So it's a great way to do a quick overview of all of the offsets you have. And if you have everything available, you can enter your offsets very quickly. You can edit stuff from here. Yeah. And of course, the big new feature is the 3D view tool. So this is an expansion of the offsets tab. So you have all of your regular offsets available, the existing offset windows available on the left side there. But we've also added this big 3D view on the right side. And I like to think of this as a QC tool. So you can see if you've done any major or obvious mistakes, like you've put in a vertical up offset instead of a vertical down offset, or you've accidentally entered a negative starboard offset and you positioned your device on the opposite side of your boat. So this is a great way to just make sure that your devices have their offsets entered accurately. So I'll just go over real quick the controls here, and they are visible on this window at the bottom, so you'll always have the controls visible. But they're very simple. You hold left click to rotate, you hold right click to pan the camera around, and you scroll to zoom the window. So there's a few, the 3D view itself is a very clean and very clear display of your devices and their offsets. So to facilitate that and to sort of hold true to that, we have the positions and rotation will update live. So as you're typing in your offsets and rotations, you'll see your device moving in real time. It's a very quick and easy way to see if you've made any big mistakes. We also have these offset lines. So there's these black bars that lead to your device, or they'll be red if it's your current device. The current device will be highlighted. So in this example, the simulation multi-beam at the bottom is your current selected device. So you can see it shows a bold, and the offset lines leading to it are highlighted in red. There's also offset labels. So you can see the vertical, forward and starboard axis labels. And there are also measurement ticks, and those will just be in whatever units your geodesy are set to. There's a few new options in addition to the 3D view on the Offsets tab. We have the Reset View button, which will very simply reset your camera to center in case you get lost. We also have this Device 3D Shape Options window. So when you click this, it pops up a little dialog, and you can do things like change your the model used to represent the device or boat. We support 3OD files and 3DS files. We also have the ability to modify the 3D shape, so you can do things like stretch it out or rotate it or change the position. And it's important to note that these offsets that you do in here do not affect your device offsets. These only affect the 3D model in the 3D view. So if you load up a model and it's facing the wrong way, or if it's way too large or way too small, or if your mounting point is in a different position, you can change the 3D offsets for just the model to get a more accurate idea of what your hardware setup here is. And of course, we have lighting options. So I'm going to actually jump out of the presentation here and run a quick demo for you guys. So hopefully you can still see my screen here. I just have the shell open, and it's the same way you access hardware. It's the same hardware program. So you click the hardware setup button, and it appears on the wrong monitor, and you'll see your regular hardware program here. And the first thing I'll show off is the All Offsets tab. So like the name implies, when you click on the All Offsets tab, you can see all of the device offsets in one place. You can come in here and you can edit them. So if you know that your GPS is mounted, 5 feet starboard, you can enter that here. If it's 3 feet forward, you can go through and enter all of your offsets and rotations here. The next thing you'll notice, when you have just the hardware option at the very top on the left here selected, you don't have your offsets tab. That only appears once you select either the boat or a device. So if we have the boat selected, we can go, the first thing we'll notice is actually that there is the taller device list. And if we go to the offsets tab, we'll see the 3D view. So on the right side here, again, the controls are visible right at the bottom. If you hold the left mouse button and move your mouse around, you'll start rotating the view, and you can see your vessel and all of its attached devices update in real time here. Let me make this bigger so you guys get a better view. And if I scroll in and out, it'll zoom in or out. And if I hold the right mouse button, I can pan the camera around and zoom in on different parts. And if I realize that I've gotten myself lost and I don't know what I'm looking at, I can click the Reset View button and it'll snap you right back to the start here. So let's spin this around so we get a nice angle here. One thing you might notice is that all of these options are grayed out, and that's because we have the boat selected along the left. So the boat does not have any offsets. So what we can do is click the Boat 3D Shape Options button here. And that pops up this little dialog box. And like I mentioned before, you can choose a new 3D shape to represent your boat. You can change the position, rotations, scaling for the boat. We won't do that just yet because I want to keep the boat looking reasonable while we move through the rest of the features here. So I'm going to cancel. And on the left side again, we can click through our devices and we'll see that the active device becomes the highlighted device in the 3D view. So I have the simulation multi-beam selected, and that becomes the bold device here in the view. I can select the magnet and have the magnet highlighted. Same for the GPS. And I can adjust these offsets in real time. So if I figure out that I have a negative vertical offset for my GPS, I can enter that and it updates immediately as I type. So I can do whatever values I want and those will update immediately. And we also chose a little arrow to represent all of these devices as the default shape. And that helps when you're doing things like adjusting rotation. So you can enter your 90 degrees of pitch, 90 degrees of yaw, and 90 degrees of roll. And you can see that the arrow is pointing and in the orientation of whatever you've set here. And just to reiterate, this button here, the Device 3D Shape Options button, this affects whatever device you have selected on the left side. So before we had the boat selected, so it would have been affecting, these settings would have affected the boat. And now that we have the GPS selected, these settings will affect the GPS. So if I click on the Browse button, it brings up this little window and I can choose to represent this with another shape. Maybe I want to use a 747 for my GPS. So if I click Apply, we now have this big bright red 747 representing our GPS in probably an orientation that most 747s aren't meant to fly in. And we can scale it up and scale it down. Maybe we want a really wide 747 to represent our GPS. And yeah, it's a bit silly to use the 747, but if you have a device shape for your GPS or for your sonar or whatever, you can load that in here and adjust its scale and size so that it matches its real world proportions. So I'm going to back out of that. And yeah, we'll jump right back into the presentation here. Let me close this. So that's some of the new features in our hardware. These are available to download off of the HYPACK website. If you're having trouble finding where to find the link, you can either contact HYPACK support or you can poke around the website. It's pretty easy to find. So next thing I want to move into is Sidescan survey signal, and specifically the signal, as I feel like it's a pretty technical part of Sidescan survey, but it's also very important to understand how it works and why you may be seeing certain artifacts or not be getting as good a signal as you want. So this section is going to focus primarily on avoiding this artifact that I call stair stepping. So you can see at the top here, we have a side scan signal coming in. And it has these odd blocks. So you can see here we have a dim signal, and then right about here, it takes a step up in brightness, and then another step up in brightness, and then another, and that's on both sides. I call that stair stepping. And on the bottom here, we have a nice, clean, bright, sharp signal with no stair stepping artifacts. And the stair stepping is because of a very low input signal. And this section of the presentation is going to focus on getting a very good input signal. Because if you have good input, then you can get good output. But if you have garbage in, you're going to get garbage out. So if you've ever opened up the signal window in Sidescan Survey, which I hope most of you have, you'll see this chart pop up. And along the left side is a scale. In this instance, it's ranging from 0 to about 1,000 on the top image. This scale is entirely arbitrary. It doesn't correlate to really anything measurable. It's entirely dependent on changes between devices. It changes between manufacturers. Some devices send a signal scale from 0 to 500. Some of them send it from 0 to 10 million. And yeah, so it's arbitrary, but it's also very important. And I also want to go over the difference between a raw signal and a processed signal. So the raw signal is what's coming straight from the device. That is also what gets written to your hard drive. So we don't save any gains or adjustments to the image during survey to the hard drive. That would be your process signal. That's when we've applied gains. That only affects the display. That is not written to your hard drive. And that is by design, that is by intention. Because we want to save exactly what the device gives us. We want to minimize our risk of modifying or corrupting the data as it gets written. So why do we see this stair-stepping artifact? That's because in HYPACK we apply gain in steps. And when you have a very, very low input signal, those steps become very far apart and they become very dramatic. So if we're applying a gain step of, we're increasing the gain by 1, but our signal is only going from 0 to 20, like I said, it's an arbitrary signal, but if it's ranging from 0 to 20, a step of 1 is a 5% brightness increase, which is pretty huge. If we have a high signal, a high input signal, a gain change of 1 is going to be much, much less noticeable. Say we're running from a signal from 0 to 1,000. If our gain increases by 1, we're going to see a 0.1% gain increase. And those gain steps happen much closer together. So it makes the stair-stepping artifact entirely invisible when you have a good input signal. So the first couple steps, and you should be doing this every time you have either a new device or a new configuration for the device, or even if you're in a new bottom type for your sonar, for your survey. The first thing we want to do is look at the raw signal, and it's pretty easy. So you're going to click on the Sidescan Signal button in Sidescan Survey, and you want to turn off the processed signal. So this checkbox is very important. When you are doing your initial setup of your device, you're going to want that off, because this is going to show you, when it's unchecked, it will show you the raw signal, which is what gets written to the hard drive, and it's what the device is outputting. So that is very important that we see it that way, because when it is checked, it is applying gains to the signal. And now we're not seeing what's written to the disk, we're seeing what is shown to the display, which, if you're applying gains, is not what gets written to the disk. So the most important thing to take away here is leave this box unchecked for the first part of your setup. Once you have that box unchecked, you can click the scale bars on the left of the signal view to scale your signal until it's roughly halfway up. I like to get it about halfway up to see the range on the left. So you can see the signal graph here is moving, maybe not fully halfway up in this specific instance, but we have a good idea of what the strength of our signal is here. So the next step is to bring your survey over a flat area, your sonar over a flat area. That means you're not doing this in a tank, and you're not doing this on the deck of your boat. You're doing this in the water in the area that you're going to be surveying. Now that you're over this area and you're receiving pings back, you want to make sure that the scale along the left is a high number. That means we have a high input signal, which means we're going to avoid the stair stepping that we saw before. High signals are maybe 200 or higher. So in this instance, we see that the signal is peaking at around 1,000, which is perfect. That's exactly what we want. In the second instance, at the bottom of the screen, we see that the signal is peaking just under 128, which means we have a low signal input, and this is going to result in stair stepping and artifacts in your signal. So you want to avoid a low input signal. So what do you do if your input signal is low? Well, you're going to want to change the strength of the signal coming from your device. You do not want to apply gains to this signal to bring its brightness up, because, like I said before, we have a bad signal in, then we're going to get bad gain outputs. So if you are in the gain tab on your Sidescan options window, you're in the wrong place. Instead, what you should be doing is looking at the device controls for your device, which are available under the device controls window in Sidescan Survey, or you can be adjusting it in your manufacturer's control software. This is different for each device. As much as I'd love to go over the setup for the dozens of Sidescan devices we have here, we have available in HYPACK, it's not feasible. So I'm going to actually move to Sidescan Survey to show you a demo of how the signal is going to look. So if I open up Sidescan Survey here, and I go to playback and load up a little file here. Let me turn off. All right, so the first thing that might happen is you're going to come in and you won't see your signal view. So what you'll want to do is click on the Sidescan signal button here, and that will pop up this window. And this might actually also show up very small. So what you can do is grab this little slider between the signal and the waterfall, and you can drag that down to make it a little bigger. Another thing that might happen is you might already be applying gains, either from a previous setup or from loading an older project up. So for this step, we want to turn off all gains. So if we click on the options window here, it brings up the Sidescan options. We'll want to change it to the gain tab along the left. And from this dropdown, we want to turn off our gains. And you'll see that we immediately have no gains. The next thing we want to do is turn off our processed signal. At this point, because we're applying no gains, there's no difference between the processed signal and the unprocessed signal. But for now, we're going to leave it off. And the next step is we want to scale this up or down until our signal until we have a good idea of the strength of our signal. So we can see that this data set in particular does have a very good, very bright signal. So we are seeing peaks over 500, close to 1,000. And that means that we have a nice big range of signal strength to play with when we're applying gains. And that's going to avoid any artifacts such as the stair stepping that we saw earlier. So that's just a quick overview of how to bring up the Sidescan signal window and how to do a quick analysis of it. In a perfect world, it would be just this quick. You would see that, okay, yep, we have a great signal. We can go off and do our survey now. But let's say that you came in here and it was very low. That's the point that you'd want to either move into the device controls window, which with our playback device, we don't have one, or move into your manufacturer's software and make some adjustments to your signal strength to bring up this raw signal so that it's not, so that it has a decently high range. And it's expected that the very ends of your signal swath are going to be pretty low. So if that's low, it'd be great if it's high, but if it's low, it's not the end of the world. So I'm going to jump back into the presentation here. So now that we have a good raw input signal, this nice high bright input signal that's going to help us avoid getting this stair-stepping artifact and other oddities when we do processing. What do we do now? Well, now we can apply gains. Just to reiterate, these gains do not affect what's written to the hard drive. That's why I've put it last, because frankly, it's the least important part of your Sidescan survey, especially if you're, mostly if you're doing um, post-processing on your data. If you're doing real-time mosaics, this is actually will affect your data. So this part is more important for those of you who use the real-time mosaic feature in Sidescan survey. So it's a little complicated, but if you're writing it, basically the only thing to remember is if you're writing an HSX file, this data does not get saved. And if you're doing a real-time mosaic, this does get saved. And I'm assuming most of you know what gains are, but just for the sake of it, all they really do is brighten the signal. And generally that brightening factor gets increased the farther away from the transducer you move, because you're getting a weaker signal at those ranges. So now that we want to apply gain, we can turn back on the processed signal button. This only happens once we realize that we have a great and bright input signal, raw input signal. So when we check this box, we are now looking at the signal after gains have been applied. So now that that box is checked, we can bring up that Sidescan controls window that I showed you before, go back to the gains tab like I showed you before, and we can choose a gain. And there's a lot of gains in here. So sometimes people ask, which are the best gains? And very simply, Auto TVG is one of my favorites. It's very easy, very quick and simple. It's a single slider that you can use to adjust your brightness. And another favorite of mine is the decibels over 100 meters option. This one gives you a little bit more control over your raw signal, and it has fewer artifacts. And I'll get into what I mean by artifacts right now. So Auto TVG again is a set it and forget it. You just turn it on, and boom, you're getting you're already 90% of the way there. There's a sensitivity slider that you'll see in that gains window when you select Auto TVG. Feel free to adjust that and slide that to affect the brightness. There's also a checkbox called Across Track Smoothing, and you can see here in the top example, we don't have any smoothing, and this, I should first mention what these blue lines are. So these blue lines, the white line is your signal, which we've seen before. These blue lines here are your minimum and maximum brightness. So if your signal is passing, the closer your signal is to one of these lines, the brighter or darker it's going to be. And this is going to wiggle and change over time as you go through your survey. There's a button here called Across Track Smoothing. And what that'll do is it'll take this kind of jagged, spiky looking blue line and just do a simple smoothing over the length of it. A lot of this is up to visual preference, as a lot of things in Sidescan are. So the decibels over 100 meters is, it's a little more, I don't know if I would call it stable, but I guess you sort of need to understand how Auto TVG works. Auto TVG uses the raw input signal to determine its TVG curve, which is why it'll change and wiggle over time. And we'll see that when I show you the demo in a second. Which means that if you have a sudden brightness change, the Auto TVG curve is going to react to that. So sometimes you might see, if you go over something metal and your brightness suddenly spikes over that metal bit, you can sometimes see this sort of streaking as you pass over it, and that's the Auto TVG curve adjusting its brightness to accommodate that sudden spike in reflectivity. But this, the decibels over 100 meters does not do the same thing. It is a fixed curve, at least depending on how you set the slider. So it does not react to the signal, so you're not going to get these those smearing effects that you get with auto TVG. When you select the decibels over 100 meters option, you're going to have, it's just a single slider. Really it's two, but it's port and starboard, so most of the time you're going to leave those linked together unless you really want to fine tune your image. And what that slider does is affects how much gain it's applying over time. So what you want to do as you adjust that slider is look at your signal window. The changes you make to that slider are going to apply immediately as you drag it. So it's very easy to see changes. And what you want to do is make your signal appear as flat across the swath as possible. So you can see in this first image we have the signal kind of looks like it's frowning. It starts very low on the left, and then it brings up high in the middle, and then it curves back down on the right. You don't want that. And in the second image, we have an example of a smiling signal. So it starts high on the left, dips down low towards the middle, and then spikes back up on the right side. Neither of those are ideal. We want a nice flat signal curve. So you can see here in the third example, the signal stays flat, mostly flat throughout the entire swath. That is what we ideally want. And once you have a nice flat signal, there you can click and drag on, it's a little hard to see in this image, but we'll show you in the demo. You can click and drag on these green bars in the signal window and slide those up and down, and that sets the maximum brightness. So the lower you set that, the brighter your image will be. And again, we'll see that in the demo coming up right now. So back in Sidescan Survey, I hope you can all still see my window. If I click play here on our playback window. So we've already determined that we have a nice good input signal. So we're going to check the process signal button at this point. No gain is being applied, so there won't be any change. If I bring up the Sidescan options window, which is right to the left of your Sidescan signal button, you can also get to that by going view options. You'll first end up on the colors tab. If you click the gain tab along the left, you can set your gain. So the first thing we'll show is the auto TVG option. And you can see immediately we have a much brighter image. Let me make this a little bit bigger. So yeah, again, the slider, the blue lines here are your maximum and minimum brightness. And as of course this signal gets lower towards the ends of the swath, those blue bars descend to meet it. And you can grab and drag this slider here to affect your brightness. So if you have a very high sensitivity, it's going to be very close to the signal. And if you have a very low sensitivity, it's going to make a darker image because it's going to be farther from the signal. And the cross-track smoothing, if you watch those blue lines again along the left, if I turn that off, you can see they become very spiky. And if I turn that back on, it's a much smoother across-track line. It's really a up to you, user preference, whether or not you want that on. It doesn't make a dramatic impact on the imagery, but it can be nicer to look at. So that's the auto TVG. It's the set it and forget it option. And the next one I want to show is the decibels over 100 meters. So I have actually already set this to a reasonable level, but we can show what it might come in as. It might come in like this. And you can see that your signal here is frowning. So the outer edges are low and the middle is higher. And if I take this slider and I drag it all the way to the top, well, it's going to go off the signal graph here. But if I bring the signal graph a little lower, you can see that it's making a smile with the signal. The outer edges are very high and the inner edges are the middle is very low. So what you're going to want to do is drag this slider, and you can see it updates in real time as I drag, and it's going to get a little low here, so I can't really tell too well what I'm doing, so I'm going to adjust the scale a bit more. You're going to drag this until it's nice and flat. So in this instance, 35 or 40 looks pretty good. I'm going to go with 35. Another cool trick is if you have your mouse over this little slider and you have a scroll bar on it, or if you're if you're not using a touchpad, you can scroll it up and down, and it's going to adjust the brightness. So little trick there. And that works for any slider. That's just a fun Windows thing. So now that we have the signal graph appearing flat and straight, if I pretend like our signal bars were in wacky places that were not great, you can see here that our waterfall is coming in with an odd brightness. The first thing you want to look at is where your brightness bars here are on this signal window. So as I click and drag, you can see that there's this blue-green bar that's following my mouse. I'm right now adjusting the port side brightness. So you can see as I drag it way low, the brightness on the port side becomes very bright. If I drag it up, it becomes very dark. So what I like to do is get my signal kind of in the middle, and then I like to bring this brightness down to where we're just starting, some of the signal is just starting to clip the blue bar here, the blue-green bar, and you can see that now we have a nice bright image here. And I'll do the same thing on the right side. It looks like the starboard side is a bit brighter, so that bar is going to go a little bit higher. Maybe they had a little bit of a tilt when they were acquiring this. So yeah, that's the decibels over 100 meters gain. It's a little more involved, but I think I like having the extra control over my signal. And again, it does not have the smearing artifacts that can sometimes show up when there's brightness changes with the auto TVG. There's also a lower bar on these in the signal window. So as I was adjusting the upper bar before to adjust the brightness, I can drag the lower bar up to make the darkers darker. So if I drag this up about here, you can see we have a more contrasty image on the port side, as we have set the lower bounds for our gain just a little bit higher. And I'll do the same thing on the starboard side. And now we have a little more contrasty image, perhaps a little too contrasty, but this is mostly user preference. So yeah, the decibels over 100 meters is a little more involved. If you're looking for a challenge, you can use that. And we'll jump back to the presentation here. Actually, let me jump right back. The other gain options, the basic gains option, this is the time that the stair-stepping artifacts show up the most obviously, and it's also a very, very simple gain. I don't like it. All it does is adds gain the farther away from the center you are, so you can see that even though we had a very, very dim signal along the edges, it's just taken that and curved it straight up. So I don't like to use that one. And then there's the formula gain. This is a bit more technical. I won't be going over it here, but if you're a technical user and you understand the formula, of course you can use that. So that really just leaves most users with auto TVG and decibels over 100 meters. Auto TVG is generally going to be what most people are going to use. And quickly, I want to jump back to this just to show you what unchecking processed signal does to the signal graph here. If I turn this off, you can see that we can jump quickly back to what the raw signal looked like. This doesn't affect the waterfall. It just affects the signal graph. So this is before gains are applied. And if I check this off, you can see what the imagery, the signal looks like with gains applied. So that's why it's important to leave this unchecked, because you could be looking at this and have a very low input signal, but because you're applying gains, it might look like you have a nice bright input signal. So you want to make sure that this is unchecked when you're checking your input signal. All right, so now we're going to move to the Q&A section.
Thank you, Daniel. That was a great presentation. and we hope this gave everyone a better understanding of our improved 3D hardware and side scan tips and tricks. So we're going to start the Q&A section of the webinar, but I want to remind you all of our special promotion that's going on. We are giving 50% off for new customers for office products and 25% off to current users. And to get better understanding of the details of this promotion and more information, we suggest you contact sales@hypack.com and mention promo code HYPACK20. And also I want to remind everyone about our HYPACK 2021 virtual training event. Registration will open in a week or so, and we will have over 25 training sessions only to those who register. And you will also be able to get to network with 20 of the industry's leading exhibitors. So it's going to be a great opportunity. So please join us. So now there were a lot of questions, so we're going to get started with the Q&A section. And if your question goes unanswered, we'll follow up via email.
All right. So yeah, we have a couple questions here. One of the questions was, can we export the all offsets table to in hardware to a CSV or a PDF or an Excel? Currently, we don't have that feature, but it's definitely planned to be added. So you'll be able to export that table view to an Excel spreadsheet or CSV or whatever you'd like. Another question is, if I load my own 3D model for the in 3D hardware, will it be accurate to its real-world counterpart? And the answer to that is I would not rely on the 3D view to be your I wouldn't rely on the 3D view to be your to use as measurements. So if you bring in a boat, your own boat model, and it looks like your GPS is slightly off from where you think from where it looks like it is in the real world, you should be relying on your real world measurements only, and not on what your 3D model shows you as positioning, because the 3D model might not be entirely accurate. There's any number of things that could be wrong. The scaling could be slightly off. So it's definitely more of a QC tool to look for obvious errors in your measurements. So it is unlikely that any 3D model you bring in is going to exactly match your real world measurements. So again, use your real world measurements before, use your real world measurements and use the 3D view as your QC tool, basically. Another question we had was, do these features already exist in HYPACK 2020? They do, and they are available for download on our website. If I pull it up, I'm hesitant to pull up my web browser here, but it is available for download. It wasn't in the base HYPACK 2020 release, but if you have, I believe, the Q2 release or further, those options are available, or these features are available. And another question we had was just to go over how we boost the signal strength for their device to avoid the stair-stepping issue. And that would be to go into your either the Sidescan survey device controls window or your manufacturer's control software and edit in there. Do not rely on the gain window to boost your signal strength. Yeah, I think that's most of the questions we had that were answerable here. The webinar will be available to download.
Yes, the webinar will be available to download after this. And And yes, unfortunately, we're out of time now, so we're going to wrap it up. There were a few questions that went unanswered, so we will get back to you via email within the week. We do want to thank you for all your participation and hope you enjoyed the webinar today. And please don't hesitate to contact us. We can be reached at sales@hypack.com, and you can check us out on social media, our Facebook, Twitter, and LinkedIn pages for upcoming news and updates. So we hope to talk to you soon, and we hope everyone had a great rest of the day.